Hello everyone. This is a quick tutorial for introduction to Simulink. So I already have the MATLAB environment open, and if I were to get to the Simulink, I could either in the Home tab click on the Simulink button, which I'm going to do right now. And this will open this window for me. I'm going to close this, or in the command window, I can just type Simulink and press enter. And this will do the same thing for me. So this is the welcome page or the welcome window for the Simulink, which basically allows you to do different things. This is similar to if you, for example, have Microsoft Office, the main page that when you open the software and gives you multiple options on how to deal with or work with the software. So on the left-hand side, you will have some opening projects, some recent projects that you have worked on. In the middle, you do have some options to create a blank model or work with other things that are more advanced, particularly if you were to work with version controlling in GitHub or generate code for hardware. We will start with a blank model, but before we get there, we are now in the new tab. There are two other tabs, that is examples and learn. So in the examples, you will get access to publicly available examples for Simulink models from other users and by the software company MATLAB or MathWork, that they have created some models that are already there for you to open, work with, and investigate, and hopefully learn from or use them in your other projects. So this is to get some previously worked on examples that are available to you to explore. And then there's the Learn tab, which gives you additional information or additional resources to start learning about Simulink, how to work with it in different aspects and for different applications. Now we go back to the New tab and we go back to the blank model. So I'm going to click on the Create Model button, and this will open a new window for me. So this is going to be my Simulink environment or my Simulink canvas. So the blank page or the blank area, the white area in the middle is called the canvas. I'm going to maximize this so we can get a better look. Now, let's go through the tabs quickly. The first tab that we have in here is called Simulation. So the Simulation tab is going to help us with creating a new Simulink model, open, save, and print, which are the basic functions. We do have the library button, which is the important portion. So it basically gives us all the important blocks that we can work with in Simulink. Remember that the concept of Simulink is to work with or to replicate block diagrams or your system model in a visual way. One of the ways you can do that is with block diagrams. And in the block diagram concept, you do have multiple blocks that will create a model together when they're interconnected. The library will allow us to choose from. So I'm going to click on the library, and it will open a new window where I can see the collection of all the block sets or libraries I have access to. Remember that Simulink can be added on, meaning that some of these blocks that you see here, for example, the aerospace block set or control system toolbox, they are add-ons to the basic MATLAB Simulink version, meaning you can add or remove them if you have access to them depending on your licensing or if you're going to pay extra to acquire these additional block sets for your purposes or projects that you're working on. But the Simulink main blocks or the basic blocks should be available with the basic version, and you should have access to them most of the time. Now, from these block sets, as you can see, they are categorized by purpose into different categories. From these categories, the ones that are important or more important to us are first the commonly used blocks, which as the name suggests are the blocks that are commonly used. So you probably will use the blocks that are in these block sets or in this category a lot more often than you would from any other categories. We then have the sources, which basically is the blocks that can generate signals or inputs for us. We will use these blocks to generate signals that we can feed to other blocks. The next category is sinks. So the sink is basically the blocks that we can either visualize or visually see our signals or output them to or store them in memory or send them back to MATLAB workspace so we can work with them there. We then have the continuous block, which is useful when you are working with your state space models. For example, you have the state space block, or if you have a PID control that you want to work with, or your transfer functions that you want to work with, which are all important block sets in control, specifically when you are modeling your systems and you're trying to add controllers to your systems. We do have the math operation block, which basically has some of the math operations. As you're building your models, as you're trying to connect signals to one another or subtract from one another, you will need these mathematical operations to be able to conduct or build the actual equations you have in your models. So the math operations will become useful as you try to build or complete your modeling in Simulink. We do have the discontinuities. So we will have some saturation, for example, block, which is useful if you want to avoid saturation in your systems. And we may get to them later on as we discuss some examples in particular models and how you can implement them in Simulink. And signal routing, which is important when you are working with combining and extracting signals. So if you were to put multiple signals to one signal or extract one signal to multiple signals for different purposes, and we may look at them. And this also has the data store read and write, which basically allows you to read and write to the memory. Another interesting one is the dashboard. So the dashboard category allows you to visually see some of the signals that you're working with or interact with your models as with a live interaction as you're running your model. So for example, with the sliders or the knob, you would be able to change values in your model as you're running it and see the instantaneous effect it has on your system response. And we may get to some of these later on as well, but this is also another way that is very useful or interesting to look at if you were to create actual dashboards that are visual and interactive for your Simulink model. So now that we have looked at all the important categories under the Simulink library, let's go back to the different tabs before we get started on the simple model. So we were in the simulation tab and we discussed library or library browser. And here you do have some options for the simulation, which basically allows you to change your stop time or how long you want your model to run. It will allow you to run step back, step forward, and stop your simulation, which we will get to as we go through. But this tab will basically be where you need to input your blocks or import your blocks from the library, run the quick settings here, and then run your model and take a look. The next tab we will look at will be debug. So in the debug tab, which is a more advanced tab, you would like to look at what could be the cause of the errors that you may get from your Simulink model. And this can happen due to many reasons. One of the most common ones is the incompatibility of the dimensions of the signals that you're sending from one block to another. So MATLAB or Simulink wouldn't be able to do the math operations or the integration you needed to because there is just a mismatch for the dimension. And using this tab, you would be able to, for example, remove some of the block or disable some of the blocks to be able to find a source of where the cause or the root cause of the issue may be. In addition, you would be able to look at some performances, if you can make your model faster, if you can remove or reduce or combine some of the elements to be able to make the performance of your model better. But that is, again, a more advanced tab. You first need to be able to create and play with some of these tools before you get to debugging and being able to improve the performance of the model you have. The next tab is the Modeling tab. So the Modeling tab will give you additional information or additional tools to work with your model, improve its performance that you have to evaluate and manage. You can change the settings of your model. So if I click on this setting button, we get to another window, and this window will give us additional options. One of the important ones in this configuration or model setting. So you do have the start and stop time, which you could also change from the simulation tab. But the solver selection is another important one. The solver selection by default, as you see, is a variable step with an automatic solver selection. Remember that these numerical simulations are based on numerical integrations or differentiations. And for those, you do need a step size. So by default, MATLAB and Simulink will decide or choose a variable step, meaning they will decide what will be the step size at any given point that gives you the fastest, best response. But it may not necessarily be what you need or what works best for your model. And for the solver, if I click on this drop-down menu, you can see there are multiple models that are using multiple methods. And depending on these methods, depending on the complexity of the model or system you have, you may get a best performance with any of them. So by default, Simulink will try to find the best match or best solver for your system. But if you see that it's not working, it may be that that decision by Simulink is not the best decision for your model. So you do have the ability to go back and change this to a manual selection and also change the step size to a fixed step. And with that, if I click on solver details, you would be able to change these variables as well. And the fixed step size can also be automatically selected by Simulink, or you can choose a step size that is manual by yourself and depending on, again, the system that you have. We will try to look at these later on as we work on some examples, but this is basically what you will be mostly dealing with if you would need to change anything with your model. The other tabs are a little bit more expert or advanced tabs, so you don't need to get to them at this point in the introduction, but you may need to change some of the things in the solver selection and the step size for your system. I'm going to get out of this window. We're going to continue with the Modeling tab. Another important block in here is the components you can add. So we do have a drop-down menu of components we can add, and we can see the library browser is here as well. But something that we will be using, and it's important to know where you can find it, is a subsystem. So a subsystem will be a collection of components that can be packaged in a system itself and can be used in another system. We will look at an example of this later on, but for now, this is where you can find the subsystem. And just so you see, I'm going to click on this so you see what it does. So if I click on this, we see that it's adding a subsystem here. And if I double click on this, we see that it has one input, one output. If I double click on this, you see here in the navigation, I have my model, then another tab that is subsystem. So it means that now I am in the subsystem. If you change the name of your subsystem, the name will appear here. Now I have one input, one output. The route from which the input goes to output can be completely changed. So you have the ability to change how your input is manipulated to get to your output. And you can add multiple blocks from your Simulink library to be able to manipulate that. And we will work on those later on. But This will be useful if you do have models that can be divided into subsystems or submodels, or you have systems, for example, if you have electromechanical systems that have an electrical portion and a mechanical portion, and you want to model the mechanical and the electrical portion separately into two different subsystems, and then connect them into your main model so that visually everything makes sense and you can categorize them properly. I'm going to click on the untitled to go back to my main model, and I'm going to right click on this subsystem and try to delete it. So to be able to delete it, I am going to click, then on my keyboard I'm going to press delete, so it will delete the block from my model. So that will be the how to insert a subsystem in your model, which is important and will be very useful. Now let's get to the next tab. The Format tab is useful for cosmetic, so to make your models more readable, more visually appealing, and as you can see, you do have multiple options for example, the fonts and paragraphs, for text, for auto-arranging the layout of your model, which can be helpful if you do have a very crowded model, and for changing the foreground, background, and the styling of your model. One of the main things that is very important here in the Format tab is the Screenshot tab. Often, when you're making a model and you need to provide a report for your project, for your manuscript, for your thesis, whatever that may be, you need to somehow in the report show visually how your block diagram or your Simulink model looks. The Screenshot tab will help you create a screenshot of the model you have, and then you can copy and paste it to your report, for example, a Word document. If I click on the screenshot, we see two options. One is send a bitmap to clipboard. Two, send a Windows meta file to clipboard. We discussed this in MATLAB introduction that the suggestion for best output or the highest quality with the minimum size output would be the vector format. So if you click on the send bitmap to clipboard, it will send a bitmap version, a raster or a pixel-based image to clipboard, meaning that you have a higher file size or a larger size file size, and you will have a pixelated version of your model if you try to zoom into the document or print it. Sending the meta file to clipboard will create a vector version or send a vector version of your Simulink model to clipboard, so it will have a smaller size or file size, and it will have higher quality and it will scale when you try to zoom in the document or print it, so it will not lose quality. So if you're asked to show the model or include it in your report or project, the best way to do it and the recommendation to do it is to use this Windows Metafile option, send it to clipboard, and then paste it in your Microsoft Word document, for example. We will do an example today after we go through some basics, but this is where you find the screenshot and how you can copy a screenshot of your model to clipboard and then use it in your reports. The final tab is the Apps tab. We discussed the Apps tab in Introduction to MATLAB, and this is a similar approach, but for Simulink. So here you do have the add-ons, which you can add additional components to your Simulink. And we already see that we do have some apps here, for example, the model discretizer that you can change continuous model to discrete model. And another option that you see here is a 3D animation player. So you do have a 3D animation player here, which can be used to connect your Simulink models to a 3D player or a 3D environment. And let's say I do have a car and I'm modeling its speed, and I want to visually see a 3D version of that model as I'm running my simulation and how that car is driving or how fast it's going. So it will be useful to visually animate the outcomes of or the results of your simulation and show it to an end user or your audience. And you can add these as many packages as available depending on, again, the needs and the model that you're working on. But again, this is going to be useful as a packaged set of tools and settings that can be helping you better demonstrate the outcomes of your system or change your system for you to work better or perform better. So now that we have gone through the tabs at the top, there are some other buttons on the left-hand side of the canvas. So if we look at these, the first button that we see is a zoom. So basically you can zoom into any portion of your canvas. The second option that is very useful is fit to view. What it does is if you do have multiple elements or multiple blocks in your canvas and they are not either too small or too big, if you click on this, this will make sure that all the blocks are fitting to 100% or consuming 100% of your canvas size. So everything will become just the right size for you to view. And particularly if you were to take a screenshot, this will help make sure that what you're taking a screenshot of is the full size, the best proportions that you need. Next, you do have the sample time. So if you have a model, if you remember, we talked about the step size, that can somehow be related to your sample time. And this will basically show the sample time on each signal. You may have different blocks and they have input-output signals, and the input-output signals may not have the same sampling time. So this will help you visually see the sampling time, and this will help you investigate if there is an issue, what could be causing the issue, especially with the sampling time. Next, you do have the annotation, which basically helps you add text or other types of annotation, for example, equations to your system model if you need to. And you can also have the option to add latex equations or text here as well, which can be useful, especially if you were to import it to another system or take a screenshot of. You can add images. So if you have images of your system or anything that could be useful to further describe the information about your model. And finally, you have area, which basically is useful if you were to highlight a portion of your model as a particular subsystem or a particular variation of the system you're modeling. So this can be useful for that purpose. We will try to look at these as we go through some examples later, but these are the basic functionalities. And then you do have some other options here that are view marked or not view marked, which basically is helping you with the screenshot you're taking to include some options in it or not. But we're not really worried about these two buttons right now. We will try to go through some of the functionalities of these buttons here and some of the blocks that we have seen in the library. So to start with, let's go back to the library and let's go back to the commonly used blocks. So for the very basic model, what I'm going to do, I'm going to go to sources. I want to generate a signal. So I want to generate a sine wave. I'm going to find the sine wave block, click on it, drag and drop it on my canvas, and then go back, and I want to see how that is, or a manipulation of my sine wave is, somehow. So I'm going to go to my sinks category under Simulink Library Browser, and I'm going to find the scope. So the scope is basically the oscilloscope, which you probably have seen in some of your laboratories. And I'm going to, again, select this, drag and drop it on my canvas. So I do have a source that is a sine wave. I do have a sink that is a scope. But I don't want to exactly see what the source is. I want to manipulate my source. To do that, I'm going to go to commonly used blocks, and I'm going to try to find a block that is called gain. So basically, the gain block is a multiplication block. whatever goes into this block will be multiplied by whatever the gain is for that gain block, and then the output will be the multiplication of the input by the gain. So I have 3 blocks, a very simple system. Now, as you see, as I was dragging and dropping these blocks, the size on the screen are sort of small. We can go and use the functionality, the fit to view. So if I go and click on this fit to view, you see that all my blocks are now zoomed in or expanded. So they are taking the 100% of the canvas size. But I also see that they are not fully aligned. So if I click on one of them and try to drag and move them, you see that I see some markers on the screen that shows me whether they are vertically or horizontally aligned or not. So now I see that these 2 blocks are aligned, and as I'm moving them, you see that there is a signal created here. But the scope is not aligned, so I'm going to move the scope. Now I see that it's aligned with my source and gain blocks. And I'm going to click on this signal and I'm going to press delete to remove the connection. And additionally, what we want to do is we want to connect these blocks, because for them to be able to interact, they need to have input and output. So if you see an arrow going out of a block, this means it's an output. So for this source block, there's nothing going into it, but something is going out of it. So it does have output, but it doesn't have input. Now I want to connect the output of my source block to the input of my gain block. To do that, I'm going to click on the out arrow from my source block, hold my mouse, the left mouse button. As you see, and now I have a red dashed arrow. I'm going to drag it all the way to the input arrow for my gain block. And when I see the actual arrow forming, I can let go of my left mouse button. And now there is a connection with my source and my gain block. I can do the same for my gain output and my scope input. So now all my blocks are connected. So I have a connection or a signal from my source, which is a sine wave, to my gain block, and from my gain block to my scope. Now let's look at the properties of the sine wave block. I'm going to double click on the sine wave and it will open the properties of this block. You see in the description that says that sine wave output is a sine wave as O, which is the output, which is equal to amplitude. So the amplitude can be changed here, multiplied by the sine of frequency, frequency can be changed here, times t, which is basically the time in the simulation, plus phase, which can be changed here, plus bias, which can be changed here. We also have a sampling time for each block. If you remember, we said if we click on this button, we can see the sampling time for signals. By default, if the sampling time is 0, this means that the sampling time is inherited, meaning each signal is going to inherit or take the sampling time of the signal that is going into it and take it to produce the signal that is going out of it as output. So if we leave it as 0, it will just use what is the default in the Simulink properties. You may never have to change these sampling times, but they particularly become important if you need to work with hardware in your model, or if you have a hardware in the loop kind of system that do have different sampling times, and the sampling times can be different from what your Simulink model is working with. So you have to make sure that they match for your full system to properly work. So now let's say I leave everything as is, which means I will have a sine wave with an amplitude of 1 and frequency of 1 radian per second. I click OK. I have the gain block. If I double click the gain block, I see the properties of my gain block. The gain is 1, and I do have an option to select how the multiplication for the gain will be. By default, as you see, it's element-wise, which is the multiplying every element of the input by the gain. But you can have other options. So if you have matrices that you need to multiply in a certain way, you can also choose the matrix multiplication here. Because we just have one sine wave and one scalar gain, we leave it as the element-wise and it should work fine for us. But you may have to change it if you're working with matrices later on and trying to build more complex systems. So I want to change the gain from 1 to 5 and click OK. And as I do, notice that this 1 will change to 5. So now we see 5. So what I'm expecting to see is I do have a sine wave with an amplitude of 1 and frequency of 1 radian per second that is going to my gain block and is being multiplied by 5. So this 5 should change the amplitude of my sine wave from 1 to 5. So my sine wave should go from plus 5 to negative 5 instead of plus 1 to negative 1. And the output of this, which should be the sine wave with amplitude of 5, will go to my scope. So I should be able to see in my scope that sine wave. But before we run this simulation for this simple model, I need to check my stop time. I need to know how long I want my simulation to run. By default, it is set to 10. So if I run this, I should see a 10-second simulation for my system. Now let's run this simulation. You can use Ctrl+T on your keyboard or press this play or start button. When I press this, we would see that the model is compiling at the bottom, and then once it finishes and runs, you should be able to either hear a beep from your computer, or if you don't and everything goes well, you shouldn't see any red screens or any errors on your system or display, and you should be able to look at the outputs. Now, I'm going to see my outputs, I'm going to double click my scope, and double clicking my scope should open a plot or the scope figure that shows me how I can use this, or what is the output of what has been sent to my scope. So here we see that we do have a sine wave. We see that the maximum is at 5, the minimum is at -5. So the gain has worked, and we have a sine wave with amplitudes of 5 and the frequency of 1 radian per second. Now, this is great if I do have only one signal, right? But what if I did have two signals? So to do that, let's make some changes to our models. I'm going to close this scope. I'm going to try to add another block or another gain block. To do that, I'm going to select the gain block I have. I'm going to copy and paste this block. So Control-C to copy the block, and then Control-V to paste the block. Now I do have an additional gain block. What I want to do is I want to have two different gains, 1, 5, and then 1, 2. So to change one of them to 2, I'm going to double click, change the gain from 5 to 2, press OK. Now I see this is 2. Now I want to send the same sine signal to both of these. So I will have two different signals, one with amplitude of 5, one with amplitude of 2. And then to do that, I'm going to do the reverse of what I did from originally to connect the block. So I'm going to start from the input of my gain, click, hold, and drag. Now we see the red arrow appearing again. And I'm doing this because I want to connect it to an already existing signal. So I'm going to drag it all the way to an existing signal. And once I see this new signal appearing, the full arrow appearing, I let it go. And now the input generated by the sine wave block is going to be sent to the 5 gain and the 2 gain with two different signals. But I also want to see both of them in the scope. The issue right now is I do have only one input to my scope. So what do? I can double click on my scope. I can click on the settings, which is the gear button here. And I can change the number of inputs, which is by default 1 to 2. When I do that, I can also choose the layout of this. So I can leave with 1, which basically is a 1 by 1 row, and it will show me the overlapped version of my inputs to the scope. So if we leave it for 1 for now, the other issue we would face would be that if we are looking at two different signals, how do we know which one is which? Because there's nothing showing here. So we can go to Display tab here and check off Show Legend. And when we do, we will be able to see the signal name for each of the figures that we are looking. So if I click OK, I should be able to see the signal names. And notice that now I will have two inputs. So I can connect my second gain to the second input of the scope, and I should be able to run this. So let's go and run this simulation. And let's look at the scope. So now we see that we have two different signals, one red, one blue, and one has the amplitude of 2, one has the amplitude of 5, but the names look gain and gain 1. Where do these names come from? These names are coming from the name of the blocks that is producing them. So gain is for the 5, and gain 1 is for the gain 2 block. But if I want to have proper names or meaningful names, I can double click on any of these arrows or signals and give them a name. So I can say AMP5 and then double click on the other one and say AMP2. And if I run my simulation again and open my scope, I now see the actual signal names that are going into my scope. So it will be very useful for me to identify what I'm looking at. And this will be also useful if you're overlapping your figures or inputs. We said in the layout, we can also choose a different layout. So let's say I want to have two different plots, two vertical plots or subplots. So if I choose this layout, click OK, we see now the inputs are separated into two subplots, but they still have their legend name and the title, so I can distinguish them in two different plots. Depending on what kind of applications you have, what you really want to convey or express with your plots, different layouts can be useful in how you're achieving that goal. But in here, we are just showing you the different ways you can use this to demonstrate that output. So now that we have a plot, the next thing is how do I get this plot to show on a presentation or in my report? Similar to MATLAB plots, you do have option to copy these. So we can go to File. This is not an Edit menu like it was in the MATLAB figures. Now it is in the File menu, and I can say Copy to Clipboard. So if I say Copy to Clipboard, and then go to a Word file, and then it actually hasn't copied, so I have to go and say Copy to Clipboard again. Now it's copied, so I can paste it. And as you see, when I copy and paste using this way, what it does, it changes the look of my plots to how the default look in the MATLAB plots are. However, there is a problem here. The problem is that it is only copying my figures in bitmap or raster or pixel-based format. So if I zoom into this, you see that the blurriness is appearing. So what I can do to fix this are two things. One is I can go to this scope output. I can go and say print to figure. So using this will basically open a MATLAB plot for me, and I put them side by side, that is going to look exactly the same as my Simulink output, but now instead is a MATLAB figure instead of a Simulink figure. So now you see I have the edit, and I can go and say copy figure, and now go to my Microsoft Word document and then paste the new figure here. As you see, this is trying to replicate the look of how it looked in the Simulink, not how it looks in MATLAB. And it is not as clear, but if I zoom in, I see that it is not still in the vector format. So the next thing you should be able to do to fix this issue is to be able to output the information from your Simulink and then plot them in MATLAB. So to do that, we go back to our Simulink model, and we are going to try to output this information to Simulink. For that, we are going to go to Library, we are going to go to Sinks, and then we are going to use a block called toWorkspace. So this basically allows to output the signals that we have to Workspace, and then use the Workspace as the intermediate place to be able to interact with Simulink outputs, inputs, and then plot them directly there. So I'm going, as you see, my canvas has become crowded, so I'm going to use this option, and I can actually zoom out with the mouse wheel to be able to move my blocks around. I'm going to move the out.sim out. So in this one, I'm going to say I want the name of my output will be amp5. So you see that the name is changed to out.amp5. I copy paste this block. And then the other one I want it to be amp2. Now I'm going to connect my output signals to their respective signals. Then arrange them to fit properly. And also double click on these units to see what I'm looking at. So here I don't want to save these as time series. I want to save them as arrays. And I want to save them as 2D arrays. Click OK. Now everything should be good. And let's go back and look at the MATLAB environment. So if we look at the MATLAB environment, we see that we do have an out variable here. But if we double click on this, we do not really see anything except T-out. So T-out is just the simulation time that is stored here. But if I go now and run my Simulink model, now it's compiled, ran, and if I go back to my MATLAB environment and look at my out variable again, I see I have the T out, and I have amp2 and amp5. So the T out is the time associated with each calculation in my Simulink. So what I see is I do have 51 elements or 51 calculations for my Simulink model. If I were to plot this, I can use plot T out. Remember that they are stored in out, which is a structure. So I need to put out dot T out, comma, out.amp2 and out.tout, comma, out.amp5. But as we learned in MATLAB, I want to also give it a specific color. So I want the amp2 to be red, and I want the amp5 to be blue. So if I press enter, it should plot the information for me. But because I had the figures already open, now that you see they are open already in the new figure, I'm going to close this figure and I'm going to run this command again. And we see that it's opening the plot for me, and it is plotting it as I wanted it to. But let's go and create a quick script so we can have more control over how it looks. So I'm going to go to Home tab, create a new script, save this script, plot script, and I'm going to just copy and paste this line. But I also want to add legend to these, so I want it to be amp2 and amp5. X label, time in seconds, and Y label, amplitude without any units, and title, sine wave with 2 amplitudes. So now I'm going to run this code. It should open the new window for me, and it should have my 2 sine waves, my legend, title, X and Y label. Now with this, if I go to Export tab and click on Copy as Vector Graphic, I can go back to my Word document and now try to paste this new version. And we will see that this version, as I zoom in, is in vector format, so the quality does not degrade. So this is how you can get high quality outputs from your Simulink models. And as you create more signals and more outputs, this will be more useful as you are going to get a lot more results and you need more visualizations. And this will give you full control over how your plots can look and all the different options you can change about how your figures look, how they feel, and what you want to focus on. So this is for the plots. But now let's select everything here and delete them. We go back to our Simulink model. And in addition to what we did with the output, we also want to have this actual Simulink model in our report as well. So as we said earlier, we can go to Format and we can go to Screenshot, and I'm going to show you the 2 different options. So at first I'm going to send bitmap to clipboard, and it gives me a notification that is now stored in clipboard. I go back to my Word document and I click Paste. We see that it is saved, stored, but in a bitmap format. So if I zoom in, I should see a little bit of blurriness around the edges. But if I want the vector format of this, I can go back to the Simulink model, click on a screenshot, and send meta file to clipboard. Doing this, going back to my Simulink, my Word file, and pasting it, I should get a vector format of this. And as I zoom in, you should see that the quality does not degrade with the zoom. So you do have a high quality version in vector format of your Simulink model that you can use to showcase in your reports and presentations when you're discussing the model you have created. So to review quickly, we talked about the Simulink environment, how you can create a new canvas, how you can add your Simulink blocks from the library browser from different categories depending on the needs, how you can change some of the feels and looks of these blocks, and how to export, look at the outputs, change the type of output you can look at, plot them, get the output in vector format, and also get the Simulink model in vector format. Just a quick note also is, as we discussed in the format block, you can change the look and feel. So let's say I want to change the background of this to yellow so that it looks different in my model, or just to distinguish specific blocks that are related to one another in my model. I can do that in the format block. And this will be useful to better communicate the different aspects of your model. So if I go here and I go to send Windows meta file and I go back to my Word document and I paste this version, now we see the colored version is there and it can be more communicative. So we will try to discuss additional options as we go through some examples later on, but this would be the quick introduction to Simulink environment from MATLAB and Simulink package.